Hello friends, welcome to another interview preparation session. So we had completed Python, basics of data science and some statistics. So today we will be continuing with statistics, then we'll be moving towards algorithms in machine learning. So let's start with today's first question. What is univariate analysis? So when we are dealing with a single column, that is when we have a single variable and we do analysis on it, it is known as univariate analysis. In other terms, we can say analyzing the data with only one variable or a single column is called as univariate analysis. Yeah, Anand, correct. So this allows us to understand the pattern and trends in the data, basically. So next, what is bivariate analysis? No, overfitting is, I don't think comes under this. This is the analysis, means we are analyzing the data set. So this is before modeling. So univariate analysis, you can say it allows us to understand the patterns and trends in the data. So bivariate analysis is the analysis of bivariate analysis allows analyzes the data with two variables. So here it allows us to understand the relation between the variables. So for example, we can give when we are analyzing data that contains temperature and altitude. So with varying temperature, with varying altitude, the temperature varies. So that is an example of bivariate. So next, What is multivariate? Friends, so what is multivariate if anyone knows? Yeah, power, correct. So multivariate is when we have more than two variables and we analyze the data. It is known as multivariate. So this allows us to let me write down. Allows us to understand the effect of all other variables on a single variable. Okay, so this is done. Next, what are outliers and how to deal with them? The power, correct. It affects the mean. Yeah, Anand. Basically, outliers are the most extreme values which affect the distribution of the uh, data we have. So, how do we treat them? How can we treat them? The correct power. So, we can drop them, either drop them if they are too extreme and we cannot uh, normalize it, we will drop them. Then we can also change the model because some models handle outliers better than the other. Then we can do is normalize the data. Or we can use algorithms. which are not affected by outliers. So the most famous example of this is random forest. Okay, so let's go to the next one. What is covariance? Yeah, also Winsorization. I forgot. Okay, so next, what is covariance? Yeah, power correct. So covariance is the extent to which variables change together in a cycle. Yeah. So this explains the systematic relation between a pair of variables where changes in one affects the change in other. So we have the formula for covariance. So if we have covariance of x comma y, so it is nothing but sum of, I don't have the symbol, so I'm writing it directly. Sum of x I means the x variable, ith variable, minus sample mean of x bar, multiplied by yi minus y bar. And whole is divided by population. So we have this formula for covariance. Next, what is correlation? So power already has given us the answer to that also. So correlation is used to measure and estimate the quantitative relation between two variables. It measures how strong the two variables are related. Yeah, power correct. So for correlation, we have the formula correlation of x comma y. Yeah, correct. Or covariance of x comma y divided by standard deviation of x into standard deviation of y. So what is standard deviation next? Okay, let us do a dual question. Standard deviation and variance, because these two are related. Yeah, power, correct. So variance is the measure of how far each number is from the mean, and standard deviation is the amount of variation or dispersion of that variable from the mean. Yeah, so basically variance is summation xi minus x bar by sample mean m minus 1, and root over of this is standard deviation. Okay, so coming to the next question, what is central limit theorem? The power, correct. Okay, so what is central limit theorem? Yeah, power, correct. So central limit theorem states that distribution of the sample mean approximates a normal distribution as the sample size is increased. So greater than 30 is generally considered to be sufficient to hold the central limit theorem. Yeah, so basically it is the distribution of sample means approximates a normal distribution as the sample size gets larger, and it does not depend upon the population distribution. Okay, so let's go to the next one. What is hypothesis testing? Yeah, so friends, what is hypothesis testing? Yeah, correct. So it is a form of statistical inference that uses data from the sample to draw conclusion about a population's parameter or a population's distribution. Yeah. So let's see. Next question. Steps in hypothesis testing. So basically, what are the steps in hypothesis testing? Okay, so I will say this. First, what we do is we make an assumption. Make an assumption about the parameter or the distribution. Let's take about a parameter. Make an assumption about a parameter. So we call this H0 or null hypothesis. Next, we make another assumption. Yeah, power. Those are the tests for hypothesis. So next what we do is we make an alternate hypothesis, HA, alternate hypothesis is HA, which is opposite of the null hypothesis, equal to opposite of null hypothesis. Then we do the tests as Power said, normality test, sample test, ANOVA, Shapiro, all that we do. So using the sample data, we do the test. Using sample data, we test whether H0 means null hypothesis is true or not. Means if it is false, it can be rejected. So if H0 is false and it is rejected, if H null hypothesis is rejected, then HA or the alternate hypothesis holds. If not, then H0 holds. So the different parameters on which we can test this is the mean, proportion, variance, standard deviation, median, all those things. Okay, so let's go to the next one. What is p-value? Yeah, it is also called as probability value. So it is a measure of how likely the sample results are, assuming that likelihood of sample results, assuming that H0 is null hypothesis is true. Likelihood of sample results likelihood of sample results, assuming null hypothesis is true. So if lesser is the p-value, we can, means if p-value is less, we can reject the null hypothesis. Okay, so regarding null hypothesis, we have two kinds of errors. Errors in hypothesis testing. Yeah, probability, obviously it ranges from 0 to 1. Shreyas. Yeah, so p-value, if p-value is low, basically null hypothesis is rejected. Yeah, so alpha, beta, or type 1 or type 2 error. Basically type 1, which is also alpha. And type 2, which is beta. So what happens in type 1 error is when we are rejecting the null hypothesis, but it is true. And null hypothesis is true, still we are rejecting it, then a type 1 error occurs. So when H0 is true and we reject it, So in this condition, type 1 error occurs. And in type 2, when H0 is false, and we are accepting it. Then this kind of type 2 error occurs. Yeah, power correct. So we'll keep the statistics till this. Let's move to the questions in data science regarding algorithms. So let's take the first question from algorithms. What is linear regression? Yeah, correct. So basically, linear regression is the linear relationship between output dependent and independent variables. First of all, we should say it is a supervised learning algorithm which finds out the linear relationship between two variables. Yeah, correct, Naveen. Yeah, so I'm coming to that assumptions part. So what are the assumptions we make for linear regression? Okay, so yeah, correct. So first, the sample we take, sample should be a representative of the population. Yeah, so next, linear relationship should be there. Equal variance should be there. all the variables should be independent. Power basically has mentioned all the assumptions, and it should be normally distributed. Okay, so what happens if these assumptions are not followed? Basically, what happens when assumptions are violated? So there are two kinds of violation. One is light and strong. Light violation means minor violations. We can tackle with minor violations in the modeling part. But if it is having means majority of data has violations. Yeah, correct. So if majority of the data has violations, uh, we cannot use this linear model. We'll have to change the model itself. So both of these violations will have effects on the modeling part. Okay, so let's take the next one. What is logistic regression? So linear regression is a part of regression modeling, means out of classification and regression. Linear regression is used for regression only. Supervised and under supervised, it comes in regression. So what is logistic regression? Yeah, power, correct. So basically logistic regression comes under classification. So it is used when the dependent variable is binary. It works best for binary models only. Okay, so next question. Why is logistic regression so popular? Yeah, power. Yeah, correct. So why is logistic regression so popular? Okay, so when we have a binary classification problem, binary linear classification problem, this is the best model to be used, and it is very easy to realize and achieves very good performance when we are having linearly separable classes. So we can say it is very popular in the sense that it is a very good model when we are considering a binary linear classification problem. Okay, so let's take the next one. What is decision tree? Okay, so decision tree is a supervised learning algorithm which can be used both for power, correct. Yeah, Naveen, we can also say that. So it can be used for both classification and regression. So in this case, we can have both the dependent variable as numerical or categorical. So basically, let me draw the diagram. So we have something like this. So this is called the root node. This is branch node, and this is the output leaf node. The power will be coming to entropy. So each node represents the test on an attribute, and each edge denotes the outcome of that attribute, and each leaf node holds a class label. So in this way, we can find out the outcomes of decision. Okay, so let's take the next one. What is pruning? In case of decision tree? and why pruning is necessary. Why do we prune? Correct. So it is the process of removing redundant branches from a decision tree. So by pruning, we can have smaller trees which will perform better and give us performance and speed also, and great accuracy also if we prune it correctly. Yeah. So next, what is entropy? Correct. Yeah. So entropy is the measure of impurity or randomness. So it tells us how pure or impure the values of the data set are. We can also say it tells us about the variance in the data set. So let's go to the next one. What is information gain? Yes, correct, Paul. So information gain is change in variation between, means before and after entropy. Basically, we can say change in entropy before and after uh, we decide a node. So we can say when we are building a decision tree, at each step we have to create a node which decides, and we have to decide which feature we have to take as the attribute for this node. So for that decision, we use information gain, and information gain is a measure of how much entropy is reduced by a particular feature when we use that feature to split the data. So whichever feature gives us the highest information gain is chosen to split the data. Yeah. So I think we should stop here, and tomorrow we'll be continuing with this algorithm part only. Okay. Okay, thank you. Thank you, friends.